Hello and welcome back. Today we highlight some features and benefits of a kinetic drive-based vehicle from an automotive manufacturer's point of view. This video will focus on full-size pickup trucks, representing over 1.5 million new vehicles manufactured yearly in the US. Developing a new vehicle based on the kinetic drive technology requires a complete overhaul of the vehicle's propulsion system. Unlike modifying an existing vehicle with a conversion kit, a complete rethinking of component selection and operating modes allows for the full use of this technology. We start with what fuels the vehicle. Options between gasoline, diesel, electric, hydrogen, propane or others all should be available for the customer to choose. Since the engine or motor is not responsible for directly accelerating the vehicle, the required horsepower is greatly reduced and smaller engines and motors can be employed. This idea of using lower horsepower motors and engines is a huge change compared to current propulsion systems. Using smaller components equates to significant reductions in vehicle weight, cost to build, along with reduced maintenance. For a full-size pickup truck, the idea of a 50-horsepower engine being more than adequate is frankly unheard of. This claim seems unrealistic and definitely requires some explanation. Basically, the reason you have a large engine is to accelerate your vehicle. If the kinetic drive is now going to do that job, the engine's primary function will be only to excite the kinetic drive and for highway cruising. For example, if you want to accelerate a 4,000-pound vehicle from stop to 70 miles per hour, it requires about 1 million joules, or 1,345 horsepower-second of energy. So if this acceleration takes 10 seconds, the average horsepower would be 135, and in reality it would be much higher as velocity approaches 70 miles per hour. To accelerate our 4,000-pound example from 60 to 70 miles per hour over 1 second would require at least 350 horsepower. Now let's put our kinetic drive between the engine and the rear. Using only a 50 horsepower engine would require less than 30 seconds of excitation to deliver the power needed in our example. Also, in our example, there is no need for a transmission between the engine and kinetic drive, eliminating an expensive and difficult-to-repair component. Let's recap before moving on. Customer can choose fuel, smaller, lighter, less expensive engine or motor. Battery reduction for electric vehicles, no transmission needed, smaller or no engine liquid cooling required, lower overall drivetrain component count, and less complex engine control systems, just to mention a few cost savings features. This planned change brings clarity to a few aspects that have been plaguing the industry lately. First, the decision between ICE and electric vehicles, the over-complexity and reliability of modern transmissions, engines and hybrid systems. Finally, issues with the cost of electrification between battery materials, grid capacity and charging station infrastructure. The industry has been flooded with bad news and just keeps asking customers to pay more for substandard vehicles. I want to keep this video kind of short, but at the same time include some other aspects to consider. I will just go through the list now, and future videos will highlight these features if not covered already in earlier videos. Exciter only needs to run long enough to charge kinetic drive. Exciter can be set to run at optimum power, torque, efficiency, or sound level. Multiple exciters and types can be offered in vehicle configurations. Starter with flooded acid batteries can be used for initial kinetic drive excitement. Only 1/4 of the batteries are required for equivalent EV mileage. Above weight reductions are more than kinetic drive's weight. Kinetic drive adapts easily to current ICE vehicle drivetrain designs. All-wheel drive and braking capable with kinetic drive designs. Kinetic drive clutching system is easily repaired, unlike automatic transmissions. High-performance configurations and axle control is inherent in the kinetic drive design. Performance options are easily installed. Kinetic drive is adaptable to larger vehicles with even better performance numbers. Complex and unreliable hybrid electric ICE systems are not required. Considerably less ICE emissions and carbon capture designs possible. AC and power steering can be driven from Kinetic Drive and not ICE or batteries. Modular battery swap, fast-charging EV possible via smaller packs. Initial Kinetic Drive-based vehicle offering could potentially corner market. To sum it up, if you're a vehicle manufacturer, licensing the Kinetic Drive system and wrapping a vehicle around it could be the beginning of a beautiful relationship. That's enough for now. Please keep an open mind. I understand change is not always easy or welcome, but let's all stay positive. Thanks, Ray.